So here we have two processes. Heat flows out. This is an heat flows out. This is an isochoric process, so a constant volume. We have a change in pressure of 2.2 minus 1.4. This is going to be 0.8 atmospheres. So this will be considered process A. And then we have an isobaric process, so we have a constant pressure with a change in volume. This is going to be 9.3 liters minus 5.9 liters. This is going to give us 3.4 liters. And we also have an associated temperature decrease. So this will be process B. So when we're saying, for part A, they want us to find the work. So the work here only occurs in process B. Because process A is isochoric, it has the constant volume. So the work sub A will equal 0 joules because, again, there's no volume change. There's only a pressure change. However, work depends on a change in pressure. Therefore, the work in process A will equal 0. Again, it's an isochoric process. For work sub B, the work in process B, this will be equal to the pressure times the change in volume. And the pressure is going to be the pressure after process A. So here it's going to be 1.4 atmospheres because process A, of course, has already occurred. So we'll have 1.4 atmospheres. And then we have 101,325 pascals per atmosphere. Then we have 3.4 liters, and then we're going to multiply this by 1 cubic meter. There are 1,000 liters, rather, in every cubic meter, so we must convert. And we're finding that the total work in process B is going to be approximately 480 joules. So part B asks us to see what's the change in internal energy. But overall, the temperature change is going to be 0 degrees Kelvin or 0 degrees Celsius. This is because although the temperature from state 1, if we can say that before process A is considered state 1, after process A is considered state 2, and then after process B is considered state 3, we can say that the temperature at state 1 and the temperature at state 3 is going to be 0. Rather, the temperature at state 1 is going to be equal to the temperature at state 3. So this means that the change in temperature is going to be equal to 0 Kelvin. And again, it's only going to be based on the initial and final points. So even though the temperature did decrease in process B, it was only decreasing from a temperature increase due to process A. So again, it's from the initial to the final temperatures, there is no change in temperature. So this means that the delta U, the change in internal energy, is going to be 0 joules because, of course, the internal energy only depends on a change in temperature. So if the initial and final temperatures are equal to one another, no matter what happened in the middle, it doesn't matter. So the change in internal energy for part B is going to equal 0 joules. And then it's asking us for the heat transfer. So for part C, we have that the internal energy is going to be equal to Q minus W is going to equal, we know that this is going to equal 0 joules. So this means that the Q is going to equal W, which equals 480 joules. Now, again, this is positive. So if Q equals positive 480 joules, that means that the heat is going to go into the gas. So this will be our final answer for part C. And that's the end of the solution. Thank you for watching.